Hey physicists, we're going to be looking at a collision of two objects, a 3 kilogram ball and a 2 kilogram ball moving somewhat toward each other in a perfectly inelastic collision. That means that the two objects stick together. There's a loss of kinetic energy. We'll learn what that means a little bit more sometime soon. Hey, I've set up a coordinate system. I'm going to call to the right my plus x-axis. Upward on the page will be my plus y-axis. Hey, previously when we were looking at momentum, all we've been worried about really is the mass and the velocity, because everything would be moving in a straight line. We would have said that the momentum of this object was 3 kilograms times 8 meters per second, 24 kilogram meters per second. And that is true, but it does have a direction now. Hey, so a couple important things as we start analyzing this. We know that momentum is conserved. But not only is momentum conserved, but its momentum is conserved in each axis. Okay, so our initial momentum in the x-axis will equal our final momentum in the x-axis, and our initial momentum in the y-axis will equal our final momentum in the y-axis, given the condition that there are no external forces during the time of the collision. We're just going to assume that these two objects run into each other. Any type of external forces during that instant in time are going to be pretty inconsequential to the change in motion that they end up receiving. Right. Hey, so I'm going to break this up into the components. We've done this a lot with the projectile motion. Hey, I have 8 meters per second moving kind of down and to the right. Okay, that's going to be consisting of a motion to the right and a motion down. Obviously, our velocity in the x direction initial for our 3 kilogram object is going to be 8 meters per second times the cosine of 30 degrees. And I get 6.93 meters per second in the x direction. So I'm going to call that 6.93 in this table. I'm going to go ahead and fill out this table for the other values as well. This lower one we can see is at 5 meters per second, 45 degrees above the x-axis. Okay, so I've done the same thing for those other values. Notice here our initial value on the y-axis for our 3 kilograms will be negative because it's below the x-axis. Okay, so for each of the momentums, well, I guess it becomes momenta as the plural there, because I'm interested in the momentum along each axis, I'm going to take the mass times the velocity in that axis. And then I'll end up coming up with 4 values there, effectively the component form of the momentum calculations. When I look at conserving momentum, it's for the entire system, both the 3 and 2 kilogram objects. So I'll just arithmetically add my momentum in the x direction and in the y direction, just to add those. So 20.79 plus 7.08, what do I get? I get 27.87 kilogram meters per second. I'll add up for the other column as well. So I have my two momenta before the collision. That's going to be the same as the momentum after the collision. There may be sharing of momentum between the two objects, but the total momentum will remain the same. Well, let's do a little bit of other thinking about this. Hey, because it's a perfectly inelastic collision, we know our two objects are going to stick together, so we're going to have effectively a single object that has a mass of 5 kilograms. Our velocities will end up being the same for the first object and the second object. So let's do a little math here. Hey, so in the x direction, I've got 27.87 kilogram meters per second of momentum. Divide that by our 5 kilograms. That's the combined mass of the two because we have a single object now. Divide that, and I get a velocity of 5.57 meters per second. That's going to be the same for both objects because they're stuck together. And likewise, we can do the same thing on the y-axis. Okay, so I take my momentum, that negative 4.92. What does that mean? It's moving down, that negative sign. I get divided by 5 kilograms, I get negative 0.984 meters per second. That's going to be the same for both of these as well. So negative 0.984. There, I got it. Hey, so what's this object going to be moving? It's going to be moving to the right at about 5.57 meters per second. It's going to move in this direction at 0.984 meters per second. To finish this off, let's see what the velocity and direction are as well. Hey, Pythagoras will be able to help us out with this. A squared plus b squared is going to be equal to c squared. Let's do a little math with that, figure it out. Hey, so 5.57 squared plus 0.984 squared, take the square root of that, I get 5.66 meters per second. And how about that angle? The angle is going to be the inverse tangent of 0.984 divided by 5.57. I get a value of about 10.01 degrees. We could call that negative because it's below the x-axis. Interesting thing here is that center of mass, the weighted position between the two, won't change its direction. It'll just keep on moving in that direction before and after the collision, because the center of mass, because we have two objects together, has no external forces on it. All right, hey, good luck with this one.